The main class in the project demo package serves as the entry point for demonstrating the functionality of the SCRMS, presumably as a Smart City Emergency Response Management System implementation. So, dito, yung program na to begins by printing a message indicating the start of the system. So, followed by the initialization of the SCRM system through the initialize system method. So, once na-initialize na siya, program simulates the receipt of the new emergency request by creating and inserting three emergency objects into the system's binary search tree, representing emergencies of varying types, locations, and urgency levels. The system then displays all recorded emergencies in a sorted manner based on their urgency. So next, the program identifies and prints the most urgent emergency by leveraging the BST's capability, so to find the highest priority node. The program also includes optional checks for pathfinding by computing shortest routes between sample locations. So, following this, it determines the nearest responders to specific emergency location to simulate resource allocation. So, dito sa system na to, nagka-calculate ng shortest path for the most urgent emergency, dispatches the corresponding response, and deletes a specific emergency record from the BST or the binary search tree. So, finally, the program generates a summary report to reflect the updated emergency records and prints a completion message to indicate the end of the SCRMS implementation demonstration. So, itong sequence na to of operation showcases the system's capabilities and emergency management, including insertion, prioritization, pathfinding, responder allocation, dispatching, deletion, and reporting.
Greetings everyone. So today I'll be presenting the step 1 and 2 of our project. So service is designed to help coordinate emergency operations such as fire, medical, and police emergencies within a smart city. So our system po uses a graph for the city network, a hash map for managing emergency units, and a binary search tree for prioritizing emergencies by urgency. So first ng system ay yung initialize system method, which is the foundation of our system. So when called, it performs three critical tasks. First, it creates all the city location by calling the add stop method for each zone in our implementation. We have five key locations, which is the central HQ, the uptown, the downtown, riverside, and the industrial zone. So second, it establishes the road network by calling the add route method to connect these locations. So let's look muna dun sa add stop method. So first, dun sa add stop method, we check if the location already exists to prevent duplicates. If the array is full, we dynamically expand it, doubling its capacity. We also create new graph node for the location. Then we add it to our node array and increment the count. Then print. Next is the add route method. First, we find the array indices of both the from and to locations. Then we validate that both locations exist. If not, mag-aano siya ng error. Then we check if the route already exists para maiwasan yung mga duplicate. Then we add the road connection in both directions. Then lastly, we store the distance in kilometers for pathfinding later. And that's all for the step 1 and step 2.
Good day, my name is ALCARIA Gabrielle and I'm going to present the put method. The put method is designed to perform an absurd operation, meaning it will either update an existing emergency unit or insert a new one. Based on provided unit ID, the method first iterates through the existing keys using a for loop. To check for a match, if the unit is found, the method updates the corresponding unit in the value array, print a confirmation, and immediately exit using return. If the for loop completes without finding the ID, it signifies a new entry before inserting It checks if the storage is full and calls the resize method if necessary to expand the underlying array. Finally, a new unit item.
So the insert method in this code is responsible for adding a new emergency object into a binary search tree, or BST, that organizes emergencies based on their urgency. So, pag nag-insert ka ng emergency, the insert method calls the recursive helper method insert helper. So, passing the current root node and the new emergency as arguments. So, if the current node is equals to null, the insert helper creates a new emergency node to hold the emergency, effectively placing it at the correct position in the tree. The method ensures that emergencies with higher urgency values are placed on the right side of the tree, while those with lower urgency are placed on the left, maintaining a structure where the most urgent emergencies can be easily identified. After the recursive insertion is complete, yung insert method natin is mag-i-increment ng tree size to reflect the addition of the new emergency and prints a message confirming that the emergency has been successfully added. This approach allows the system to efficiently store, sort, and retrieve emergencies based dun sa kanilang urgency levels.
This part of the code is used to manage emergency using a binary search tree. In this tree, every emergency has a certain urgency level, and the tree is arranged so that the lower urgency goes to the left and higher urgency goes to the right. Because of this structure, the most urgent emergency will always be found at the rightmost side of the tree. Find most urgent method. The goal of this method is to look for the emergency with the highest urgency without removing it. It first checks if the tree is empty. If there are no emergency, it prints a message and returns nothing. If the tree is not empty, it starts at the root. It keeps moving to the right child of the node. In a BST, going right means going to a node with higher urgency. It stops only when there is no more right child. The node you end up on is the most urgent emergency. It prints the most urgent emergency and returns it. So basically, the method works by doing start at the root, go right, 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 then stop. This is the most urgent. Pop most urgent method. This method behaves almost the same as find most urgent method, but with one important difference. It removes the most urgent emergency from the tree after finding it. It checks if the tree is empty. If yes, it prints a message and stops. It again moves through the tree by going to the rightmost node. When it reaches the most urgent node, it does the two things. It returns that emergency, it removes that node from the BST, so it won't disappear again. This is useful when you want to process or handle the most urgent emergency. Then take it out of the system, just like a queue in a hospital or emergency center po.
Greetings everyone, I am Bautista Lawrence and I'll be explaining what does the finding nearest responder do. So dito po sa ating method na ito or sabihin nating class ay ang nangyayari po dito ay puro compare and contrast po with the use of for loops since ang ginagamit po natin dito mainly ay ang array. Hindi po tayo gumagamit dito ng linked list or pwede naman po gamitin pero sa case po namin gumamit po kami ng array kaya po for loops ang ginagamit po namin for compare and contrast. Balik kakailanganin po natin dalawa ng methods. Yung isa naman po shortest distance and yung isa naman po yung pinaka finding nearest responder na. Pero I will discuss first kung ano po yung ginagawa ng shortest distance. Bale meron po tayo dito makikita na tatlong array which is yung nodes and yung distance and yung visited and all of them are size are the same which is yung city count natin. Makakita rin tayo dito ng initialized na distance which is point out into 99999 and mahabang 9 which parang nag-imagine ka ng infinite number kasi imposible na makakuha tayo dito ng mas malaking number doon sa distance. Bale, balik ko lang, meron tayong parameters and ang tinatanggap niya ay ang graph and start and yung end natin. Bale, doon mangyayari yung mga compare and yung papasok doon sa mismong method. Bale, after ng ating tatlong array, magkakaroon tayo ulit ng initialize ng start index and end index and both of them will have the value of -1 that evaluates such as a none or false. And after naman nun ay magkakaroon tayo ng for loop. And dun sa for loop na yon ay magkakaroon tayo ng dalawang if. And dun sa pangunang if ay i-compare yung value ng index to equals ignore case sa start. And kapag nag-true ito, magre-return ito dun sa value ng index. And dun sa pangalawa naman ay same lang dun sa first. Pero ang kina-compare niya naman ay yung string ng end. And after naman magkakaroon tayo ng nested loops. And dun sa unang for loop na makikita sa nested loop ay dito makikita yung for loop na para mag-loop if ma-check if na-visit na lahat ng city na meron tayo. And if mag-true naman tayo dun sa unang for loop natin, pupunta naman tayo sa pangalawang for loop, which is dito nagkakaroon ng comparison if tama ba yung city and yung destination na pupuntahan nito. And if mag-true, pupunta ulit tayo dun sa pangatlong for loop. Dun sa pangatlong for loop natin ay dun na nagkakaroon ng comparison kung dun sa tatlong responder natin kung sino ba mas malapit sa kanila doon sa destination na pupuntahan natin. If tapos na ang comparison, then yung class na ito ay magre-return ng value na distance and mapupunta naman siya sa ating pangalawang class, which is yung finding nearest responder. Dito naman sa ating pangalawang class ay very simple lang siya kumpara sa kanina, since dito ay medyo same sila ng unahan, which is magde-declare ng best distance na initialize sa 9999 to implicate na ito ay infinite. Then meron dito isang for loop kung saan dito nangyayari yung pagre-return or pagbibigay ng kaninang class na shortest distance and naka-indicate siya sa data type na double. And yung kanina na best distance natin na equals to 9999, i-compare niya doon sa distance na nakuha natin sa kaninang class. And if mas maliit ito doon sa 9999, i-return niya, ay ito ang i-return ng class na tatawagin doon sa ating main. After naman doon sa dalawang method natin, ay mapupunta na tayo sa printing. Bale, ang ipiprint nito ay yung ID, ay yung type ng responder, and yung current location ng user. And then, if wala namang, and isiset niya yung availability into busy. And if wala namang responder, simple lang. Bale, magre-return lang yung system ng there are no available responder.
Greetings. So I'm JOSEL BANDONG. So I will explain the shortest path and the shortest distance in the SCRMS or Smart City Emergency Response Management System. So those class are the class that calculates the shortest path between two location or cities. So let's proceed. So the shortest path is actually just a facade. Shortest path class doesn't actually calculate anything. So it just check if that location actually exists or if that location is valid. Now the shortest distance is actually the one that calculates the minimum travel distance between two cities or locations. So again, the shortest distance is the one that calculates. So the process behind it is first it copy all graph nodes into an array called nodes, and then we create two arrays called distance and visited array. So for the distance, it just store the shortest known distance to each city, while visited array is to mark the cities that is already done and already processed. For the second step is we locate or we identify the indices of start and end. For the step 3 is just we slowly expand the outward from the start city, and we always choose the closest unvisited location. And the last part of the shortest distance is
When the algorithm finishes, the distance array contains the shortest distance to every city. Now is after that we simply return the value for the we simply return the value stored for the NCT. Now that is how shortest path and shortest distance works in our screens. Thank you.
Greetings, I'm BUTIN JOSEL and I'm going to present Dispatcher. The Dispatcher class in our code is responsible for finding the shortest distance between the two cities and for locating the nearest available emergency responder. The shortest distance method uses an algorithm to calculate the shortest path between a starting city and a destination city by checking all connected roads and updating distance. It first sets all city distances to a very large value, then sets the starting city distance to 0, and repeatedly visits the nearest unvisited city to update travel distances. After finishing the process, it returns the shortest distance to the destination city. Find the nearest responder method. Search through all emergency units in the map and check only those that are marked as available. For each available unit, it calculates the distance from the unit's current location to the incident city using the shortest distance method. It compares this distance and keep track of the unit with the shortest distance. And last, it returns the emergency unit that is closest to the incident location.
This code deletes an emergency using binary search tree or BST. It navigates the tree using a recursive helper function, which is essentially determined by the emergency's urgency level. Once the precise node is identified based on both urgency and ID, the main logic handles the three basic BST deletion scenarios: the no child, one child, and two children, to ensure that the tree stays properly structured and prioritized after the removal. The node for two children is replaced by its in-order previous node.
The Summary Manager class tracks the total emergencies, how many were dispatched or resolved, and the time when any of these values were last updated. The class updates its count and timestamp whenever an emergency is created, dispatched, resolved, or deleted. It increases the relevant counters, prints a message when a unit is dispatched, and decreases the total count if an emergency is removed. The print summary method then displays all current statistics, including totals and the last updated time.